going to go ahead and take a look at number 109 from section 4.3, logarithmic functions and their graphs. So 1/9 provides us the function f of x is equal to negative log base 5 of x. So in order to start graphing this, we want to know what transformation is happening. And we should immediately look at that negative 1 that's out in front of the logarithm. And what this is going to do is it's going to cause a reflection across the x-axis. Now to give a little bit more detail, notice that the negative is happening after you evaluate the x that's in the log. So basically what you're doing is you get your output and then you're attaching a negative to it. So what that's doing is that it's taking your answer and changing the sign that you're getting out. So basically what I'm saying is I'm changing my output or my y value signs. I'm giving it the opposite sign that I would get. So if, for example, you took the log here and you got an answer of 4 as your output, you immediately tack on a negative to make it a negative 4. Likewise, if you took the log of something and it gave you a negative 2, you immediately hit it with that negative on the outside to make it a positive 2. So first off, let's talk about what the parent function is. The parent function is going to be log base 5 of x. And this is enough information for us to go ahead and start constructing a table. And remember that with logarithmic functions, we had gone through a list of characteristics for log functions, and there are two specific points that happen with every basic log function. One of those points is going to be 1, 0, and the other point will be the base value, in this case, which is 5, and then its output value will be 1. Okay? So if I'm going to reflect something across the x-axis, that basically means I'm going to change the signs of my output or my y values. So what I'm going to go ahead and do then is multiply each y value by a negative 1. So that means that one of my points will be 1, 0, because 0 isn't going to be affected by a multiplication of a negative 1 to it. And then the next one will be 5, negative 1. Okay? So now we have enough information to go ahead and create a graph. So one thing that we want to note as well is the asymptote. The asymptote for a function usually rests right on top of the y-axis. And the only time that we're ever going to see it move, so where we will move it away from the y-axis, is if we do some sort of horizontal transformation, moving it left or right. In this case, we haven't noted any sort of horizontal transformations, so our asymptote is actually going to rest right on top of the y-axis. And we'll go ahead and we'll plot our points at 1, 0, and then at 5, negative 1. And if the reflection is causing you to feel a little bit disoriented with how the function should look, then what I would suggest doing is going ahead now and plugging in additional values for x and seeing what values you get out. Odds are you'll probably have some sort of decimal approximation, but that's okay. You're just going to have to eyeball the point on your graph. But essentially, because we're causing it to flip over the x-axis, it's going to move like so. Notice I did use what direction my points were going in order to connect them. Okay. So I'm going to actually start off hugging with the vertical asymptote, connecting with the points, and then using them to help me pivot, and then continuing on. So this is number 109. If you have any additional questions, please let me know.